Hello everyone, Rahul here again. I hope you are enjoying the lectures and I also hope that your preparation is going fine. And one more thing I wanted to tell you that please feel free to ask any doubts and questions till now you have accumulated in the comment section. So today we are going to deal with uh, some important facts about the earth which can be asked in the competitive examinations. I have accumulated the facts from various sources and many probable questions can be asked not even in UPSC but other exams also like bank PO and SSC etc. So let's move ahead. So today in this slide we are going to deal with the profile of planet, like what is its density, what is its mass, and what is at what speed it rotates, at what speed it revolves, and so on and so forth. So starting with this table, in this we have first characteristics is mass. Here you can see mass is given 5.97 into 10 to power 24 kg. Approximately it is taken as 6 into 10 to power 24 kg. It is easier to remember this way. So I have already told you that equatorial diameter is 12757 kilometer and polar diameter is 12714 kilometer. I told you before that Earth is extended from the equators and compressed from the poles. So we have more equatorial diameter and less polar diameter. Okay, and equatorial circumference. Now very important. You even don't need to remember that it is 40,075 kilometers. What is circumference? Circumference is 2 pi r, and it is equatorial. So we will use radius of diameter, equatorial diameter, that is d equatorial by 2 comes the radius, equatorial radius, and then 2 into 3.14, 2 into pi into 12714 by 2. This will come out to be equal to 40,075 kilometer. And then also orbit distance. Now Earth rotates also, revolves also. So when Earth rotates, it rotates on its own axis, and when Earth revolves, it revolves around the Sun. So this orbit distance is the distance between the Sun and the Earth. Now average distance between the Sun and the Earth is called 1 astronomical unit. Okay, 1 astronomical unit is average distance between Sun and Earth. So it is taken to be 149,598,262 kilometer, but you remember just it is 150 million. 1 million is 10 lakh. 150 million kilometers. So this much distance is there between Earth and Sun. Now orbit period we know 365.26 Earth days, in which we complete a whole year, and after 4 years we have a leap year because this 0.26 adds up to a 1 day and little extra. So speed of revolution. How can you calculate the speed of revolution? Speed of revolution can be calculated by speed is equal to, speed is equal to distance upon time. Now distance between, what distance we will take? The distance we will take is distance between Sun and Earth. The distance between Sun and Earth is, I just told you, 150 million kilometer. And what is the time? 365.26 days. In 1 year only it completes one complete circle, na? So 365.26 convert into hours, kilometer per hour. The speed will come out to be 107,280 kilometer. Similarly, speed of rotation. Now when Earth completes one rotation, 24 hours are gone. So how to calculate speed here? First of all, speed is equal to distance upon time. The distance is 2 pi r. If you suppose we take at equator, 2 pi r we just calculated above. Okay, and then what is the time? Speed is equal to distance upon time. The time is 24 hours or 23 hours 56 minutes 4 seconds. So when you calculate this, it will come out to be 1669 km per hour. Okay, The time I have already told you that it takes 23 hours, 56 minutes and 4 seconds. Now surface temperature of Earth varies from minus 88 degrees Celsius to 58 degrees Celsius, and the average temperature that we find on Earth is 15 degrees Celsius, as you see on the top, 15 degrees Celsius. Now how many Earths can fit inside the Sun? That is, Sun is an average sized star, and how many Earths can we fit in? Suppose we consider Sun as a pot, and we make a opening here. In this opening we start filling the Earths, so we can fill 1.3 million Earths. If we melt all the Earths and pour it in, 1.3 million Earths will completely fill the volume in the Sun. Okay, I will tell you how did you calculate it later. Now or I will tell you here only. You know, the volume of a sphere is 4 by 3 pi r cube. Okay, so this radius, with this radius we will find volume of Sun. We will divide by volume of Earth, so it will give us the number of Earths. Okay, now if you drill a tunnel straight through the Earth and jumped in, what will happen? First of all, you will take 42 minutes for going from one end to the other end of the Earth. That is, when you suppose this is Earth, you drill a hole here and you go through this hole, you jump inside here and you go there. This is the center of Earth. You go there and then you reach here by when 42 minutes are over. Now when you jump inside, first of all, here whole Earth is attracting you by gravitational force. You will move inside, but when you move in the Earth, this place, at this place, here the upper part is pulling you upwards and the lower part is pulling you downwards. So g will decrease, that is acceleration. That acceleration due to gravity will decrease over time. Here it is 9.8 when you jump, but over time it will decrease. At the center it will become exactly 0, because both this side and this side cancel each other. But when you because you have motion, so you will cross the center and you will not stop, even though the g or acceleration due to gravity at the center of the Earth is 0. You will move forward due to momentum, and when you go this side, this whole area, suppose you are here, this whole area will pull you up, but this area will pull you downwards. So you will start deaccelerating, and when you reach here, you completely deaccelerate. But again, you will now whole Earth is attracting you downwards, and when nothing is attracting you upwards because you are at the corner, then you move again backwards. So in this way you will keep oscillating within this hole and then this is just an assumption. Suppose if you can drill it and we consider the Earth is not hot inside, also we also negate the effect of Coriolis force, that is due to centrifugal force. Because due to centrifugal force you will bump like this, and you will already be melted before you have entered here. So let's move ahead. Time taken by light to travel from Sun to Earth, it is 8 minutes and 20 seconds. Everybody would be knowing that, but how do we calculate that? Distance upon what? Distance upon speed. Distance, you know, what is the distance? I just told you, 1 astronomical unit. Speed. So divide distance with speed, you will get 8 minutes 20 seconds. Now it should be noted here that Earth is an ellipse. That is, the orbit of Earth is an elliptical. So at some points Earth is nearer, at some points Earth is far from the Sun. So we have taken the average. The average came out to be 150 million kilometer, but it can deviate from 147 million kilometer to 152 million kilometers. At the closest point, the distance is 147 kilometer, and then the speed is the same, so the time comes out to be 490 seconds, in which the light travels from sun to earth. But if you take 152 million kilometers, the time comes out to be 507 seconds, and here it is 500 seconds. 8 minutes 20 seconds is equal to 500 seconds. Now, which is the world's deepest hole in the earth? It is Kola Super Deep Borehole. Now it is in Murmansk Oblast province is there in Russia. It is 12 kilometer approximately, 12 kilometer deep, and this Kola Super Deep Borehole was named after Kola Peninsula. It is nearby Finland, and it is between White Sea and Barents Sea. Please see in the map. It is like this is Finland here. This is Kola Peninsula, like this. Here you have White Sea. Here at the top, North Pole, towards North Pole, you have Barents Sea. Okay. How many times lightning strikes Earth? It is 100 times per second. So thank you everyone. I hope you like this lecture. Please like, comment and subscribe to www.decipheris.com, and please like our Facebook page and keep interacting with us. Your review is important, but we have not find enough comments. Please, it keeps us motivating, so please comment. Thank you.